go. There's your clicker. All right. And give it up for Wim. I forgot to do the introduction, so he'll introduce himself.
Am I? Okay.
Yeah, you need to introduce yourself. Sorry, buddy.
Okay. Yeah, so I thought I'd start. Last week he was asking me. So actually I had a recording with Mark and then he gave me lots of inspiration. So I took this title, right? But I should have pronounced it as YIN because actually there's a Henderickx YIN that is named after me. So, but unfortunately I didn't do so. How does this work? Doesn't work. Yeah, so I had a slide because in some conference they basically have a habit of giving a few words about who you are, right? So I'm from Belgium, by the way. So I was here to invite. So there is like 5 things that characterized me, right? One is I'm a runner, right? So I try to run every day. Actually, I run every day 10K, right? But so what's most important is actually that I think I'm a geek, right? So my title is CTO, right? But I'm with a big T of tech, I always say, right? And then I like to share knowledge. So all the knowledge that I gained, I like to help. That's why I'm here, probably. And so I'm flying all over the place. So I'm actually typically somewhere. And most of the time I see either Steinsy or I see Mark somewhere. And then I think what inspired a lot of the things that I will talk about is this Kubernetes thingy, right? So, and I will talk about automation. So that's kind of what brought me here. And I think one of the things that I wanted to do with this talk is how do we make progress or how can we move us forward into that automation space? Because I think you see a lot of discussions happening and I'm actually doing quite a bit of work in that space. And I want to share some of my thoughts and some of the things that I'm doing in that space, right? So that was actually the inspiration of the talk. Now, I don't know in the audience how many people are actually busy with network automation in one way, in one form or shape or another. How many? Can I see show hands? So, so like half of the audience basically is kind of busy with it, so which is awesome, right? Now there is several challenges or things that are doing so. Given that I'm more of a technical guy, right? So I took the technical sides of the house because there's also culture and people and stuff like that and knowledge and skills. So I basically focus in this talk about 2 things. One is trust, and the other one is you could say the YIN, right? And the other one is the YANG, which is basically the lifecycle management. So because there is, in my view, that is why haven't we seen so much adoption on network automation yet? We feel that many people don't trust the system, right? Because we are typically people that actually, I'm calling it the CLI jockeys, right? So we are typically used, and that's how we are trained. We go to the device and we figure it out ourselves and we do all of the stuff manually. And so the trust is not there. So without the trust, you will never change, right? So, and that's one of the challenges. The second thing is about the life cycle. And one of the things is, I always say when you do network automation, I always say you're actually building a product, right? Which means that you have to maintain it, right? Because it actually evolves. There will be new releases, there will be new changes, so you'll actually have to evolve it with it. And as a result, you have to spend time and effort to keep that up to date, right? And so that's kind of where I am focused the conversation upon right now. And I think I want to give you the big picture, right? So one of the big, so we talk, those people familiar with network automation forums, so we talk about this design-driven automation, right? So the way I try to describe it is we go from, like, you build abstractions, right? You then try to actually resolve them to the lower level constructs, right? Which is what I call the normalization, all the way up to like the configuration that actually goes onto the device, which is actually what I call the vendor specific implementation, right? And some people have only single vendor, right? Some people have more vendors. And of course, depending on that, you need more of this logic or not, right? But at the end of the day, what you have to build is you go from abstractions. You have some business logic that you have to put in place. You add some normalization, you add some more business logic and stuff like that. So if you look to the automation journey, that's kind of what you have to do, right? So you actually have to build the glue to actually go from all of these various spaces. And I think the key thing, and I'm not going to talk too much about AI and ML and all that stuff, right? But what is actually important and Mark will probably agree with me, I believe, is that the data is very important, right? And I'm a big fan, and I think it's Netbox, I think is one of the companies that actually led us in that space, is that using an API first approach to network automation, right? And a lot of people start with Python and they start with Ansible and stuff like that, and they actually do that on their laptop. But at the end of the day, the data that you use in order to do your automation is not shareable, is not reusable across many people. So as a result, doing your automation or basing your automation from data, and then the challenge, of course, what do you do with the data? But I think is a very important first step to actually go and develop an automation system that is actually maintainable, and lifecycle management actually can be used by many, many, many people, right? And that's what I had in this slide, is like, I believe, and I don't know whether we agree, so we can discuss, or maybe discuss it offline, right, is that that API first approach, but actually that data first approach is actually one of the important side of things. And why did I talk about the yin and the yang as well? Is like the challenge that we have is that when you do automation, you actually have the yin, or the dilemma between what do I do on the client and what I do on the server. So the server is actually the thing that holds the data, right? And so if we can do more on the server side that assists in the client, because the client is the thing that actually you have to build and you have to maintain, or you can, of course, ask a system integrator to do that on behalf of you, but at least someone, whether it's a vendor, a system integration, or yourself, someone needs to actually own and deal with that lifecycle, right? So, and the key things, I believe, where we have to make progress, and these are the things that I'm going to talk about, is what can we do on the server side to make it as easy as possible on the client to actually consume and actually reduce the life cycle, but also improve the trust in the automation, right? So these are the things that I'm going to discuss. And I basically took 3 challenges that I think are important with respect to trust and lifecycle management, and what approaches that I see that we should do in order to actually make progress in that space. So that's kind of a little bit the discussion. So first challenge is automation needs to evolve with the business. So in other words, I don't believe, I'm of the opinion that change is there all the time. That means that your automation or even your business evolves, right? So it's not like you build it and you're good for the next 10 years. I haven't seen that, right? So that means that once you put something in place, then either within a year or in a week, depending on what happens, is you actually have to evolve, right? How do we do that? And the thing, so the first challenge that we have is when we say, okay, we have the data, it means that the data model that we have might not be right for the new business requirements. So we have to evolve, right? So this is why the role of the schema is a very important element, right? So, and what is a schema at the end of the day? It's the definition of your attributes, right? So the VLAN, the IP addresses, the device, right? The link, the interfaces. So that's kind of what is defined through the schema. But what can happen is that your schema has to be updated, or the parameters or the attributes have to be updated depending on your business needs. And the question is, how do we do that in that world, right? So the approach that we take, and I think Mark will probably talk about that as well, is we said, okay, you take a schema, and that the schema is actually a YAML file, right? So everybody can actually use that, can update that. And we derive, so from that schema, we basically generate, and you'll see in a bit, we generate UIs, we generate SDKs, we generate CLIs. So in other words, that schema is actually able to evolve and able to evolve with your business requirements, right? And we believe that that is one of the key important building blocks that actually helps us move forward to make progress and reduce that lifecycle management. Now, of course, when you do that schema change, there are, of course, a set of challenges. For example, you have data, and how do you migrate that data to the new changes and stuff like that? But we believe that we have some technology that are there. And if you look to the system itself, if you do look at it more from the picture, what that schema actually does, actually it's built in such a way that when I load it into the server, without you having to change the code, it actually operates on behalf of the user. So what you have in the schema is all your validation rules, right? So a VLAN can be from actually 0 to 494, right? So if you try to put something in with 5,000, it will fail, right? So all of these type of, that's what I call validation rules, right? And they can be rather sophisticated. On the client side, you have all the SDKs, so all the code, so that when you have the schema, you actually regenerate for you all the code, all the data, all the artifacts are updated, even the UI is actually rendered from it. So in other words, we are trying to build a system that is easily evolvable by just updating the schema. We migrate the data for you, we update the parameters, and the reason we do so, or we believe that's important, is that to help you migrate your business requirements automatically towards the new environment that is relevant for your business at the end of the day. Now, how that looks like, for example, so on the left-hand side, I give you an example of a schema. And by the way, we are discussing how that schema should look like and how we should build and stuff like that. But at the end of the day, what you see is that we actually generate a bunch of parameters. So one of them is the UI, SDKs. But I was also of the opinion that graphing and relationships, which I'll talk to you in a bit, is a very important asset, right? And the reason why I'm saying that is the following. It's like typically, let's say this thing, right, has certain characteristics. So you have a button that moves it forward, right? And you have a pointer, so you can probably see that. So that is actually what defines this thing, right? Now, if I use it, or Steinsy use it, or Mark uses, it might behave differently because I do fast clicking and what have you. But what I'm trying to say is that the fact that I'm holding it right now will give this a certain behavior, right? But this asset is still the same thing, even if I hold it, or he holds it, or Mark holds it, right? And so this is how we have to think. So, and that's why I built this slide. So what we have done sometimes in our schemas or in our attributes, we have modeled what I call the relationship or the behavior on where this thing sits as part of the data model, right? But that means that the evolution of that thing is actually depending on who holds the hand. So that means that tomorrow, if I try to have this thing operate by 2 persons, you actually have to change the characteristic of this thing. Whereas at the end of the day, what matters is actually the fact that I'm holding that thing is an attribute. So in other words, we try to build a relationship between these 2 objects, which doesn't make that binding fixed, if you see what I'm trying to say, right? So, and that I think is an important attribute, because what that allows us to do is allows us to actually build these things in a more independent way without having very fixed dependencies and how to use it. Another example that I typically say is that, let's say you have a router and it's deployed on site A, right? But tomorrow you introduce another attribute like an availability zone, right? Do you have to update the schema of the router to do so? In my view, the answer is no. What you have to do is actually allow for a relationship to that new object to appear into the schema without actually having to update the attributes of the system, right? So that's kind of a little bit where we are doing. And the result of that is, going back to the previous slide, is that we now have graph capabilities. You see the thing on the top right as well, like this relationship. Now you can build visualizations and usage patterns automatically from that data, right? And the reason we can do so is because we built that system in such a way that the relationship and all that stuff are automatically binds to the data that is actually rendered. And that means that actually I can build a system that is actually very flexible and is actually adapting to your needs in a much faster way without you having to hard code a number of things. So that's kind of the crux. And the goal is to reduce the life cycle of the environment when your businesses evolve towards new requirements and stuff like that. Now, the second challenge, and by the way, there is more to it, but I just wanted to highlight it. So the second challenge, which I thought was, which automation framework to use, right? Or do we pick? And We have this debate on declarative versus imperative. And then we have discussion on workflow engines and what have you, right? The quick answer is, I don't care. We should enable all of it, right? Because they all have good and bad attributes. And I think we have to give you a lot of choices. Now, the way I look at is that, of course, a declarative system is way easier to operate, right? So in other words, if you look at the difference between declarative and imperative, so declarative is just the what, right? So you say, I want this thing to be deployed and or this VLAN to appear, and this automatically figures it out without you having to know all the steps and how to accomplish that. In imperative, you actually go with all the individual steps and stuff like that. So you actually have to detail all of the steps on how to accomplish a given, let's say, artifact. Now, and you can already see that a declarative approach is way easier to operate. Now, you have to design for this, right? Because I built a first declarative, so actually I built a Terraform provider in the first instance to actually interact with the router. And so the challenge was the following, is that what the declarative system does is actually it sees, okay, I need to build a diff from what you want towards the actual state and execute that diff, right? So that means that actually you have to interact with your device to fetch that data in order to do the comparison and then execute the delta. Now imagine that your data is scattered and scattered, so the amount of interactions you actually have to do with the system is way more, right? And the challenges that I faced, like if you look to a Terraform provider, you typically have a lot of these different artifacts and resources. It actually exhausted the API server of the platform, right? So how do you resolve that? You actually introduce caching, right? So in order to basically interact with the system at scale. So what I'm trying to say is declarative is the way to go if you can, but you actually have to design for it. So in the system that I'm talking about, caching is like there for everything, right? So that means that you can actually operate at scale and don't be worried about those challenges. But the most important thing is that actually, well, declarative is really nice. Without a proper design and a system that backs it up, it can be challenging, right? Now, the second thing is like workflow. We talked about the different approaches, and I put here a slide how I look at the system, right? And this is some of where my Kubernetes, let's say addiction is probably the wrong word, but what I think is important where Kubernetes differentiate versus other systems, right? So what we do typically in automation is we build so on the left-hand side is what I call a Python program, right? And in the beginning, when you build a Python program, what do? You build like one piece of code that goes from A to B, right? And you execute the job good, right? Then people say, okay, that's spaghetti code, right? So you need to make it more modular. So you build functions, you build classes and what have you, right? But still, the engine that executes that is typically a monolithic system, right? And so what you do then as a next step is you basically build what we call workflows, right? So an example of such a workflow is Ansible, or Terraform is one of those workflow systems, right? And so what you do is you basically have tasks or objects, right? And what you do is they have dependencies. So like in Ansible, you have a playbook, and in the playbook, you say, do this, do that, right? Or you can also do if, then, else statements, right? But you execute that along those lines. But what you see is that the workflow or the graph is kind of predefined by the human, right? So that means that it's very good to do a repetitive task. You know, I want to go from A to B, and you execute all of these things in order or in sequence with some if, then, else clauses, right? So it's very good at that. Where it's really bad is like if we live in a dynamic world and you don't know exactly what is going to happen at what moment in time, it actually is not that reactive to the system, right? So that's why you see what I call this choreography approach, right? It's actually, the system is a little bit different. So the tasks in that case are registered to the system. And when they get triggered, is triggered by an event when something happens, like your interface goes down, all of a sudden that task kicks in, and that task can kick in other tasks and stuff like that. So in other words, you can already see that the order and the sequence in which things execute are not predefined any longer, right? And you can build more dynamic workflows. Now, of course, within a given task, you can still have an Ansible playbook, right? So what you typically see evolving is you go from the left to the middle to the right, depending on how you scale things. And if I go to the next slide, what you then actually see is that if you take that to the next step, is that what happens is that you can actually so if you look today, we are talking about agents, right? And workflow agent and agentic systems, right? What you actually do is you have an LLM. It actually reasons about the system that you have in place, and then it starts to call tools, right? And I do tool A, then tool B, tool C, right? But how does he pick tool A or tool B or tool C? It's actually based on knowledge or based on information that you actually get to the system, right? So what you see is that with that third approach with choreography is actually, we actually give you that capability because we actually register through an event, we actually register that task to the system, right? And then someone can pick it up whenever it is needed, given a certain context that you have for your environment, right? And that's why I call collaborative automation in which humans don't really predefine it. I'm not saying that LLMs are the ones that doing, right? What I'm trying to say is that we have to think about systems in which we basically say, here are the things, or we register the tasks that actually have to be executed, but how and in which order they are being executed is actually depending on events that actually trigger them, right? And as a result, what I see is that when you actually have such an approach, you actually get way more flexible systems that are easier to maintain and so on and so forth, right? Now, the other thing that I am, see, the persons here that do automation, how many are non-Python developers? So who does not use Python to use Go or Rust or TypeScript? Is anyone raising that? So all Python? Go, okay, so one Go. So, but so I'm of the opinion, because in networking, Python is king, right? I don't disagree, but what you see is that when you go outside of the networking space, you see other languages appear, right? So I'm also of the opinion when we build the automation, I'm not purely building for networking. I want to enable as many use cases as we can, right? And that's why you also see that if you go back to the middle approach here, you typically see that there is a dependency between the language and your automation, right? Because if you go Ansible, you have basically Python. If you go Terraform, you have Go, right? So, and so although I understand why that happens, I'm of the opinion we need to actually give the choice to the consumer rather than enforcing it based on our workflow system, you see? And as a result, what I'm actually trying to accomplish is basically give you that flexibility that the programming language or the thing that actually renders or does your business logic, you can pick the one that you want. So I don't want the framework or the workflow system to actually dictate the one that you have to use depending on the system that you want. So I want to have a way more flexible way to instantiate. But long story short, I'm just giving you my perspective of the landscape. They are all valid, right? And I think you should use and pick the one that you feel are most familiar with. And what I'm trying to say is that I'm giving you the choice to be able to use everything, but give you more flexibility in order to actually grow your automation in a very natural way, right? Now, the third and last challenge is, how do I trust my automation? And related to that is keeping the data up to date, right? Because it's nice to store some data into a database, right? But given the business requirements evolve, how do I keep them up to date? And how do I relate my data to it, right? Also, what you typically see is that, okay, I did an automation, nice. Is it reproducible? Can I rerun it? Can I see if I run it, what has changed? and how that affects my systems and stuff like that. So there is a bunch of questions that I believe are important elements that actually help us gain the trust to bring that automation as a first-class citizen and move away from what I call the CLI jockeys that I typically are, by the way, guilty as hell myself, right? So what are those things, right? So one of the things, who is familiar with Git blame? All right, okay. I want to introduce Git blame to network data. So that means that if a parameter on a configuration of a platform, I want to know which automation drove that. What was the person or the element? So if you look to the data, right? So which data was actually responsible for driving that particular parameter, right? So you see here an example of it. So owner X, so it's a bit very abstracted, right? But that description foo, right, was actually coming from who? From that, let's say, intent or that data ownership. So the example is probably not very good, but I think at all points, I want to give you the ability that no matter what you do, you can always relate back what was the origin of where that particular parameter that actually enters up into the device was coming from. And as a result, I think you gain trust if you know, right? Because today what actually happens, that configuration, this ACL, who put that in? Do we throw it out? Nobody dares to touch it, right? So that is part of the problems that we are trying to solve with that, right? Second thing is, okay, I run a bunch of automation. What changed? Right? So I want to give you the view of all the objects in the database, what changed, what parameters, where do they come from and stuff like that. So it's actually giving you a full picture of the diff that also is very, let's say, nice within the Git environment. And it's not just a diff between one object, it's actually the relationship of that. Now, I probably need to improve, let's say, the visibility or how I present that, but at least I think I want to give you the sense of what I'm talking about. The third thing is actually version control, because sometimes you want to do a change and you're not sure, right? So you actually want to actually see, did that new program or that new data that or the schema. So for example, you evolve the schema. We want to give you the tools to actually say what changed. We can do a dry run, right? We can actually give visibility about things and do that in a way that you can test in your isolated environment with actually talking or impacting the real system. So you actually have what we call the version control of the Git and the dry run, but also the ability to go back in time. Let's say you did a change and it actually didn't work, that you can actually say, okay, roll back to this instance and the network is back in that state, right? So without you having to lose sleep. Okay, so that's, I think, where we believe that we have to go. And of course, in order to do so, we actually have to give you that test and what I call the digital twin to actually validate the changes that we are actually about to be doing, right? And so, yeah, that's actually the pieces that I wanted to share so far. And thank you for the time. And if there are questions, I'm happy to answer them.